welcome to the Joy News channel. Now, just about 5 days ago, the National AIDS Commission released its report on HIV infections for the year 2022. That's half of the year, January to June. And I'm sure many of you were alarmed when you realized that over 23,000 people had been infected for just the first half of 2022. That is definitely worrying, given the years of work, the years of campaign, and all that we have done to be able to keep this under control. It appears we are beginning to see some decline in the progress we've made. So, but this report also then brought into sharp focus the conversation about the treatment of HIV, well, beyond the campaign and all that we are doing to prevent people from being infected in the first place, but also managing the population. Because as it stands now, the population of infected people is well over 350. Mind you, just 71% of those people are known by the commission and are going through treatment. So what happens to the rest and how are they doing? Well, I chanced on this research work done by a researcher at the University of Ghana, and I asked myself, is this the groundbreaking research? Is this the breakthrough that we need as far as the treatment of HIV is concerned? Well, we are fortunate to have him here with us. We are at the chemistry department of the University of Ghana, and Dr. Jerry Jo Harrison as my guest. Doc, thank you very much for agreeing to speak to us.
Thanks for having me.
And before we talk about the groundbreaking research that has generated headlines, and I'm sure you had a lot of congratulatory messages in your email.
Absolutely.
Before we talk about that, let me take your initial reaction to the latest report by the Ghana AIDS Commission. 23 people between January and June. That's alarming, isn't it?
22,000, yes. I mean, that's actually disheartening to know that such large numbers of people are getting infected by the disease. I think that there is some kind of complicity. I think over the years, people have become immune to the idea that HIV still exists. And so despite all the campaign and everything, we are beginning to lose ground, like you rightly mentioned. Yeah. And so there's a wake-up call to all of us that HIV is still around and that we should take every precaution to prevent further transmission of the disease.
So, but what do you say about those who attribute, this partly to COVID-19 and its effect on public health, for instance?
Well, I mean, one could certainly not attribute this to COVID. Well, maybe the way COVID struck us unexpectedly and the mortality rates that were observed somewhere elsewhere created the impression that, well, we could be consumed all of a sudden, right. And some way, somehow we managed to survive. And that, gives people some wrong impression that they could be reckless with certain things. But I think that there's a real threat that we have to take very seriously, and we have to go back to the drawing board and start getting innovative ways, especially in this age of social media, to get people, to appreciate the fact that HIV, is still there. Yes, there are some treatments that are available, but they come at a cost, and side effects are things that we always talk about. So people should do their best to not get infected in the first place.
And I know you're a researcher, but in your interactions and your engagement with the population, with policymakers, do you find that this is a thing, the nonchalant, is it a thing with the young generation, or it's simply, a thing with the entire population?
I think that it's a general feeling. I don't think it's generational. When I interact with people and you tell them you are HIV, researcher, the first question they ask you is AIDS still there? And so I think that the problem is not a generational one, that we've all become sort of nonchalant about the disease because of the fact that it is not as deadly as it used to be. And so the fear of contracting the disease is no longer as at its peak as it used to be. And I think that's part of the problem that we're having now.
We'll talk about what you think the Ghana AIDS Commission should be doing to address this, but that brings me to your work, the research work that you have done. When I saw the headline, that there's a groundbreaking research on HIV, I thought to myself, oh, do we finally have the cure to HIV? Tell us about it. I read a bit of it, about the polyproteins of the virus and all of that, but you are the researcher. Break it down for me and my viewers.
Okay, so first of all, let me say that we don't have a cure for HIV just yet.
Okay.
I know there are many people who are working day and night trying to crack the puzzle. I mean, there are definitely bottlenecks in that process. Over the years, what we've tried to do is to try to understand the virus so that we can use its own system against it. And one of the things that we still didn't understand is how the virus is able to reproduce itself so well within, the cells. Yeah. And over the years, what we know is that the virus uses very crafty methods by one having a genome that has overlaps in there so that it can maintain a very small size. But one thing that we also observed is that for bigger animals and all that, we make each protein that we need for every process. But these viruses make these proteins as a long block. Then they chop them into smaller pieces in a process we call maturation.
Okay.
This is very unique to viruses, the polyprotein concept. And so the polyprotein presents a unique avenue for targeting the virus, since there are no equivalents within the cells of the eukaryotes that they infect.
Okay.
And for the past 40 years, we really didn't have any grasp of how these polyproteins look like and whether they're even structured in the first place. And so what me and my team have been doing over the past 6-7 years is...
Oh, that's how long it took you to come out with this research?
Oh, yes. It's going down there and developing new tools and technologies that allowed us to be able to visualize the three-dimensional structure of the enzymes that are used by the virus before they become fully active and ready to go. They come together as a polyprotein, and we wanted to see how they look like. And so that's what the work that was published was about.
Okay, so if I understand what you're saying, you're trying to deal with the rapid reproduction or maturation of the virus such that you're able to deal with it at its initial stages so that it doesn't reproduce itself quickly and then get to affect the person infected.
Yes, so we know that the virus has to be inserted into the host genome, and then from there new viruses are made. And the new viruses comprise protein and nucleic acid complexes. Okay. And so when the virus is assembled, the virus has to mature. And that maturation involves a protein Caesar that goes about cutting the proteins at specific places in that process. Okay. What we've now found is that in the initial stages before this maturation happens, the proteins look a certain way. And what we can do now is to develop drugs that can specifically stop this processing from happening. Okay. And we can stop that, the virus is completely dead. And the optimism is that because the number of proteins in this complex are so small, even if we're able to develop new drugs, we are going to need small doses because there are not many of these available. Right. And that means that potential side effects, toxicities are going to be much less. That is going to potentially improve compliance, and things like that. So we are really optimistic that now that we know how these enzymes look like, as somebody would say, in their immature stage, okay, then we can target this immature stage of the life cycle and then develop inhibitors that will be able to specifically stop this maturation process, which is required for the virus to be able to infect new cells.
Right. So help us understand how long it takes. I mean, the process from the initial stage to the maturation to the point where it begins to quickly reproduce itself. How long does it take?
So roughly it takes about 12 to 24 hours. Okay. So when the virus enters the cell, it has to undergo reverse transcription, and then the reverse transcription converts the RNA genome to DNA, and then the integrase enzyme has to take this double-strand DNA and insert it into the host genome. Then from there, new viruses begin to be produced from there. All from the time that the virus enters the cell to the time when new viruses are seen takes minimum 12 hours, and roughly within 24 hours, you start seeing viruses from the newly infected cells being produced.
That's so quick.
Absolutely.
And so what would that mean for, if at all, we have, pharmacists or, the chemistry industry picking this up to produce some medicines. What would that mean for the treatment? It means that the ability to be able to identify the infection will be crucial.
Yes. So thankfully, as of now, there are really good methods for diagnosing the disease. Yeah. Unlike some other diseases, it's very easy to diagnose it. But the treatment is where the problem is. The drugs that we currently have target the virus when it has already matured. So the mature enzymes are the ones that the drugs target. And usually once you're mature, you're more resilient. So the possibility of having resistance emerge is much higher when you target the mature enzymes. But because we didn't know how the immature enzymes look like, we haven't been able to target them all as well. And so now that we know, our hope is that we'll be able to now stop the enzyme from maturing and effectively destroy the virus, but also the barrier to genetic resistance is going to be much higher for the immature virus or the immature proteins compared to the mature proteins.
Does it mean that any time beyond the 12 hours or say 24 hours maximum, that will be too late?
Not necessarily. I mean, the thing is that so within 24 hours, the newly infected cell will start producing virus, and so it doesn't really matter. At that point, you already have the viral genome as part of your genome.
Okay.
But how the disease progresses will depend on the interventions that you take from that time.
Yeah.
And we are saying that we believe that now that we know how the immature proteins are, and we understand how their three-dimensional arrangement are, any intervention that is going to be developed for that is going to have potentially minimal side effects.
Right.
And that when the side effects are low, compliance is much higher. And there's even a possibility of having long-acting drugs that one can take only once in a while. Just about a couple of weeks ago, there's been a new drug that's been approved in Europe, lenacapavir, which targets the capsid of the virus. And guess what? That is going to be an injectable once every 6 months. So you can imagine the possibility of...
Injectable every 6 months for persons who are already infected?
For persons who are already infected. But I believe that in the long term, this will become sort of a pseudo vaccine that people could even take to prevent.
And that was the point I was coming to. I asked the earlier question about the time, given how unregular people check for HIV in our part of the world especially. And so most likely many people would discover that they are positive when the disease has matured and it's almost advanced. And so then the work that you have done, would you say will become redundant, so that then you can begin to look at the possibility of a vaccine instead of a treatment at that initial stage? So
the work doesn't become redundant in the sense that once you get infected, you are infected. And here the idea is not to prevent the infection. The infection has already happened by the time you are diagnosed. But how quickly it progresses depends on the intervention that you have. If we can stop the virus from spreading, then we decrease the viral load, and so people can lead healthy lives. But if you even get diagnosed, even at advanced stage, and the drugs are not effective, then you're going to have consequences. So the idea is that we could have a more effective drug that targets a different part of the life cycle compared to the current drug that we have that targets the mature stage of the enzyme. So until we get a vaccine or a cure, this work still remains very relevant, and even beyond, for understanding how these tiny particles are able to
But it's safe to say, that at this point, the work that you have done provides basis to be able to deal with this at a very early stage, reduce the implications. That, HIV positive patients could be more healthier.
Absolutely.
Could live much longer than we're seeing today.
Like everybody else. And the good thing about reducing the viral load below a certain point is that you can't even transmit it.
Right.
Okay. So then, if we have more effective drugs, then even in the absence of a cure, we could still get the disease eradicated, because now if you can't transmit it, then over time, all those populations that have it will die off, and then we have a brand new population that doesn't have the virus.
That's very interesting and very exciting to also note, I mean, for public health. But since you published this research, I have seen it in, the journals and many other places. Have you had any contact or input from the AIDS Commission, from the Ministry of Health, any governmental body contacting you to leverage on the work that you've done?
I spoke with one person from Ghana AIDS Commission, but that's about it. We had a brief conversation at a public engagement that we had at the beginning of the month. Yeah, but that's about it. I haven't had any contact with the Ministry of Health or any other governmental agency, unfortunately.
But your work is available?
It is available to everybody.
Wow. How about the pharmaceutical, companies?
Well, already some pharmaceutical companies have contacted me and my team and have obtained some of the reagents that we used for the work. And so I am very sure that they are actively pursuing drugs that would target this particular protein that we've shown does exist and does do the things that it does.
You're talking about pharmaceutical companies in Ghana?
No, these are pharmaceutical companies in the US.
In the US.
Yeah.
Well, that's interesting. Do we have, the current antiretroviral drugs we have in the country? They're all imported, right?
They are.
And so there's no work around, any HIV drug in the country at the moment.
Unfortunately, the R&D aspect of pharmaceutical manufacture has been really non-existent. We basically import APIs and formulate them, and that's been the story. But I think that we can do better than that. We can go.
What is the challenge?
There are a lot of research costs money, and to be able to compete favorably, time is of essence. Right. And unfortunately, it costs probably twice as much conducting research in Ghana than elsewhere. And the rest of the cost comes in the form of taxes and duty and freight. And so donor agencies are unwilling to give Ghanaian researchers the amount of money that they need to be able to do some of these.
Because these, a chunk of it are consumed by the taxes and these, statutory payments.
Absolutely. So if it's going to cost them twice as much to do the same thing here, why not give it to somebody and they'll be able to do twice as much the work? So look, as a country, we have to become serious about some of these challenges. Procurement processes alone are just enough to put off any researcher. You can't believe that you can have a grant for 1 year and for more than 6 months, you haven't been able to procure anything because there's one office, they have to go to another office, to other office, because there are laws.
You're talking about the procurement authority or the procurement laws?
The procurement laws, the people that are within the universities and research institutions, people are interpreting the procurement laws and are working with the procurement laws. But I believe strongly that these were not a thing that were anticipated when they were framing the procurement law. But they become integral part of our laws, and so people have to apply it as it is. And this has become one of the major challenges to secure research grants, because people look at the research output. Eventually you will do the work, but time is of essence. So if I'm competing with somebody elsewhere, the person can buy whatever research equipment, whatever research needs they want in a record time, then you don't stand a chance. Let me give you a typical example. When Ebola was reported in West Africa, this was back in November, December, I think of 2015, thereabout. By March, the structure of the Ebola virus, March of 2016, the structure of Ebola virus was available. I mean, how did that happen? Because they already had things in place, infrastructure-wise and everything. And this is how you make progress. When COVID, struck, laboratories were not fully equipped to deal with it, you could imagine how long it would have taken us to get a first vaccine that we did. We're able to do things in record time because labs are already fully equipped, and you could buy things not necessarily under certificate of emergency, but countries have realized that foreign direct inflows in the form of research grants is an integral component of their GDP. Australia makes almost like a quarter of their GDP from research grant and money from elsewhere. So we can absolutely benefit from something like this by simply saying that, look, if things are for research purposes, we are not going to charge any duty, you're not going to put any taxes on it, so that you order the things within the system, it comes straight to the lab, and you are already working. That way we can respond to pandemics in record time without having to think about all these bottlenecks that absolutely frustrate researchers, to be honest with you. Even if you get a grant, being able to execute it becomes a problem because the laws are such that they simply don't allow you to procure things in record time. Right. And that is a serious bottleneck, and funders are aware, and so unfortunately we are not getting the grants that we need to be able to contribute immensely towards solving some of these problems that we have.
Right. And I know that government, sought to establish the research fund. I don't know what has become of it, but perhaps these are things that they should be considering to make it more, effective.
I think so. I think in the absence of the research fund, what government can do is to restructure the procurement laws to allow for certain flexibility when it comes to especially scientific research. Because you buy these reagents, and sometimes what you think you are going to need, you buy it and it doesn't work. You have to go back and if it takes you 6 months to do your first procurement and your grant has a lifespan of 1 year, then you are not able to do anything. So we should be able to anticipate these things and put in place mechanisms that ensure that, of course, people don't abuse it. And I'm sure that within the research institutions, we can put in place mechanisms that ensure that things that people buy actually go to the research. Otherwise, I am afraid we are going to be lagging behind as we always have, and others are going to receive all the research grant. South Africa, for example, receives a huge amount of research grant. Then also reward systems in here. Elsewhere, when you publish a paper, you get rewarded, with financial incentives. In other words, you get more money to do the research. Yeah. So not that money that are coming into your pocket, but because you are contributing to solving these problems, they give you more money to be able to carry on with the research. You need to hire students, you need to buy equipment, you need to buy reagents and consumables and all that. So they give you more money so you can continue doing. Here, we don't have anything like that. And on top of it, doing research is almost like hanging yourself, because imagine you've been given money to do work and you are just running around looking for invoices and you're not getting them because we don't really manufacture anything here anyway. And yet, because that's what the law says, you have to satisfy all righteousness. And that is really killing the research drive. I don't have any doubt in my mind that if we make just for research things duty-free and tax-free, and that people can actually buy from the best vendor that is out there, we absolutely can increase our research inflows by 200% in a couple of years.
Right. I feel the frustration. Hopefully somebody will be listening and would move in that direction. But back to the Ghana AIDS Commission and of course the policymakers. What can they do with your research, and what also should we be doing to help the campaign, the fight against HIV?
Thank you. I think that at the end of the day, we are working towards one goal, and that is eradicating HIV from our continent. Unfortunately, we are the worst struck. And so the AIDS Commission can be an advocate for research, because at the end of the day, we need to be contributing to the fight, either it's in the form of diagnostics or whatever form it is. But I think at this stage, being able to advocate for government to come to the aid of people who are doing research, within that area can absolutely be critical. But I also believe that in the age of social media and all that, we should continue with the campaign for people to be cautious. The use of protection is absolutely crucial if we are going to be able to reduce the number of infections that we have, what we shouldn't lose sight of is that there are many people who are positive and don't even know. So screening is something that we should probably embark on a large scale and try to get everybody tested so that those who are positive can be given the antiretroviral medications. That way they can live healthy and they don't have to be able to even, at some point, they may not even be able to transmit to their partners. So these are things that we absolutely should be doing. I think right now we should be doing testing on a large scale, trying to find everybody that is affected, and then giving them the necessary treatment that they need so that we can control the spread of the disease.
Right. Thank you very much, Dr. Harrison.
You're
and
very
congratulations
welcome.
once again on this research. So that's Dr. Joe Harrison, Jerry Joe Harrison, a researcher here at the chemistry department of the University of Ghana. HIV is real, it's still around us, so please be safe, and don't forget the ABC of HIV, and then we can together eradicate this disease amongst us.